Hi, in this tutorial we're going to take a look at the Pydantic library. As usual, the Jupyter Notebook fully annotated is available in the GitHub repo, which I link below the video. So Pydantic is a great library for creating data models in Python, leveraging Python's built-in type hints. I actually first came across this library when I started using FastAPI for doing API development. But since then I've been using Pydantic for way more than just FastAPI. I find myself using that library practically in almost every project I write. I always need data models. I work a lot with data. I always need data models, whether it be working with, let's say, JSON documents in a NoSQL database, in a document database, or just working with general models that I may have throughout the lifetime of my code. And so Pydantic makes defining data structures or models, to use Pydantic's terminology, with strict typing very easy. Now, it's not exactly strict typing, but basically Pydantic will enforce the types that we specify for our data models at runtime. It doesn't happen at compile time, it happens at runtime. Furthermore, Pydantic provides data validation, which is what gives us this strict typing. Basically, we'll get validation exceptions if we don't have the correct types. So we're essentially guaranteed that fields in the structure will be of some specific type. But it also gives us the ability to very easily serialize and deserialize data to Python dictionary objects or even JSON, and it even supports pickling as well. And it also helps with IDE features such as inspection, type checking, auto-completion, things like that. So you will need to install Pydantic into your virtual environment, and I have the link in the Jupyter Notebook in the repo. But if you're using pipenv and you're using this repo, the pip file has the library already included in it. Otherwise, you'll just have to pip install Pydantic yourself into your virtual environment. There's also plugins for both VS Code and PyCharm that can better leverage the Pydantic models and just basically give you a better experience when you're using Pydantic models with those IDEs. So let's start by creating a very simple data model. So the first thing we're going to have to do is we're going to have to import base model from Pydantic. So base model is the base class we should inherit from in order to define Pydantic models. Let's go ahead and do that. So Pydantic model is essentially a class that inherits from base model. And in order to define fields in this model, we basically just define class attributes. So like first name, and then we'll do last name and age. But now we can type those fields. And we use that by using Python type hints. If you don't know about Python type hints, I have a video in this channel on Python type hints. So we'll say that first name should be a string. Then we'll say that last name should be a string as well. And then we'll use an age field, and that should be an int, like so. So we can now create instances of person, and those instances will have these properties or fields, to use Pydantic's terminology: first name, last name, and age. Let's go ahead and do it. Let's create an instance of person. And we'll say that first name equals Isaac, and then last name equals Newton, and then we'll say that the age is equal to 84. And now we can look at what P is. So P is a person instance, because that was from the class person, and it has first name Isaac, last name Newton, and age 84. Now watch what happens when we pass different types for those instances, for first name, last name, and age. So let's say that we say person, and then we'll say first name equals 100, last name equals 200, and age equals, let's say, the string 3. So as you can see, this does not match the types that we've defined for the person model. However, look what happens. The 100 got cast to a string. The last name, 200, got cast to a string as well, and the 3 got cast to an integer because it was possible to do so. If we had tried to do something like age equals x, then we would get an exception. Now we would be told that age, the value, is not a valid integer. Let's go back to 3. And so this is why I was saying that we're basically guaranteed to have the correct type. If Pydantic cannot cast the particular value that we give it to the appropriate type, we'll get an exception at runtime. Of course, this doesn't happen at compile time. Python is still not a statically typed language. Now, by default, the fields we defined are required, and Pydantic will raise an exception if we omit one of those values. So to do that, let's go ahead and instead of just letting it do an exception like we just got, let's go ahead and import from Pydantic. We're going to import the validation error. That's basically the main validation error that we get in Pydantic when something goes bad. So we'll import that validation error, and then we're going to try to create a person object, and we'll only specify the first name. And then we're going to catch that validation exception. And then we'll print the exception out. So let's see what happens. Indeed, we do get this validation error exception. We trapped it and we printed out. And it told us that there were 2 validation errors for this model. So as you can see, it didn't stop on the first validation error. It tried to validate everything and then gives us a summary of everything that was wrong. In this case, it tells us that last name and age are both required fields and both were missing. So we can even get this exception as a JSON string, which is useful, when you're doing, let's say, API development, because you can just basically return that saying, hey, this is the error. You might want to put other things around with it, but essentially what you get is this code, this JSON string that tells you exactly what is wrong. So it's very useful for programmatically dealing with these exceptions. Now let's actually make one of the fields optional. And we do that by simply using a type hint. So I'm going to copy, paste our original model. Let's take that. And I'm going to make age optional. So if we're using Python 3.10 and above, we can basically use the or. So we can say the age is an int or none. And that essentially says age is optional, and it will then be none if it's missing. So for person, first name equals Isaac, and last name. So those 2 are still required, but age is no longer required. And when we do that, you can see we no longer have an exception, and age just comes back as none. Now, if you're working with prior versions of Python, prior to 3.10, then it doesn't support this operator here. Instead, what you'll have to do is from typing import optional. That's one way of doing it. And then you would just redefine this way. We would say optional int. And then you'd get the exact same thing happening. Now, if instead of doing this, we could actually specify a default value, in which case the optional is no longer necessary. So let's go ahead and do that. Let's say for class person, we'll say the first name string equals none. That's the default value. So essentially, it's saying the same thing as saying that first name is optional. And then instead of doing that int here, we're going to say int equals none, right? So we're not going to specify optional. We're going to do it this way. And so now we can create a person object with just the last name. And we can make that Newton. And as you can see, first name is none, age is none. Now, of course, we don't have to specify none for the default. We could have said, this is the default for this field. So now when we create a person instance, we get first name Isaac. So let's go back to none. Now we can also serialize this data model to a Python dictionary. So instead of dealing with this instance of the person class, we can actually transform that into a Python dictionary. And very simple to do. We just take the person object and we say transform it to a dict. And this was the original person object that we had. So let me go ahead and redefine it just in case. And we get the same serialization. We can also serialize directly to JSON. So you could certainly just take this dictionary and then use Python's JSON module, use the dump s function, and then get a JSON string out of it. Or we can just use Pydantic directly, which provides this JSON method. And then here you go. We have this JSON object. You'll notice that it is a string, right? We have the quote symbols on either side. Now, when we serialize the data, we can actually opt to exclude or include only certain fields. So for example, let's say we don't want to serialize everything that's in that person object. So we could, again, call the dict method, but we're going to pass it a named variable, exclude. And exclude needs to be a set, and the set is going to be strings corresponding to the names of the fields in the model. So in this case, let's say that I want to exclude first name and age, which would be the same thing as saying I only want to include last name. And I'll show you include in a second. So when we do that, you can see that our serialization, our dictionary, only contains last name. So that's pretty handy as well. And of course, it works the same way with the JSON as well. So we can go ahead and say print p.json. And in this case, I'm going to include, and I'll only include, let's say, last name. And I guess I'll include the two of them as well, just to show you that, again, it is a set of strings. And furthermore, what happens with the JSON method is that any named argument that it receives that it doesn't understand, that Pydantic doesn't understand, it passes along to what it uses internally for serializing, which is JSON's dump s function. So we know that the JSON dump s function can take in an indent as a named parameter. So we're going to do that, and that's basically going to indent our JSON with 4 spaces. That's really all that does, and I'm doing that just so we can get a nice, clear representation. And so basically it only shows us last name and age. It only included those two, and it excluded first name. Now, just like Pydantic can serialize a model to a Python dictionary or a JSON string, it can also deserialize either, basically go the other way around. It can start from a dictionary or a JSON string and create an instance of the model for us. And it will cast the data appropriately. And this very often avoids a lot of the legwork that may be required for JSON serialization and deserialization. Let's take a look at this, and let's actually add a date to our model, for example. So from datetime, I'm going to import date. And then we're going to take our model again, and I'll just take those first 2 fields. And I'm going to create a different field here called DOB for date of birth, and that needs to be a date. And let's go ahead and create this dated dictionary, which I'm just going to copy from the notebook and the repo, so I don't have to retype everything. And you can see that it contains first name as a key in the dictionary, last name in DOB, and actually a date object in the dictionary. And now we can actually load that up by saying p equals person dot parse object. So that's the method that we can use, parse object. And we'll use data as the parameter. We're going to give it that dictionary. So now this is going to go from the dictionary to the person object, right? This is called deserialization. And if we look at the object P, it is indeed a person object. And we can see that date of birth is an actual date object. Now that shouldn't be too surprising given that the dictionary started off with a date object. What happens if we didn't have a date object? Let's say that this was actually a string. And let's go ahead and create the string. Let's say 1643-01-04. So this is a standard ISO format. And we can go ahead and do the same deserialization, and we'll look at what P is. And you can see that it deserialized this string into an actual date object. So it was able to do that conversion. And the same thing will happen with the JSON as well. If we start with a JSON string, let me copy paste that from the notebook. So if we start with the string, again, date of birth is just a string in here. And we can now use the p equals person dot, and now it's called parse raw. If you're going to parse JSON, you use the parse raw method, and you pass it the JSON string. And then if we look at what p is, you can see it's the same thing. It got deserialized into a person object with the correct types for each of the fields. Now you can of course override how to deserialize values in your JSON objects. You can do that by deserializing the JSON string yourself using the load s function, for example, in Python's JSON module. You can create your own custom JSON decoder, and you can do other techniques to override how you decode and do a custom decoding. And then you can use the parse object method from Pydantic to now go ahead and deserialize the dictionary back into a person. But there is a simpler way of doing that and baking that right into the Pydantic model itself, and we'll come back to that in a bit. Now, one thing you may have noticed is that the Pydantic model uses snake case for field names, since that's the convention for Python code. But in JSON, we typically use camel case. Now, Pydantic supports this. Let's go ahead and do that. And what I mean by this is that in the Python code, I want to use snake case for first name, first underscore name. That's the standard that we have with variable names, field names, things like that in Python. However, in JSON, that's not the case. First name should really be first with a lowercase f, no underscore, and a capital N. That's what we really want to do when we're emitting JSON if we want to be compliant with the standard naming conventions for JSON. So from Pydantic, we're going to import the field object, the field class. And we're going to use that to expand how we define a field in our class. And that field is going to give us a little bit more control than just the type hints by themselves. In particular, field has a way for us to specify an alias. So let's go ahead and do that. Let me grab the class again so I don't have to retype it. And what I'm going to do here is, instead of saying it's equal to none, I'm going to say it's equal to a field instance. I'm going to set the default equals to none. So that's the same thing as if I had just said equals none as it stands there. But field supports more than just the default named argument. I can also specify an alias, and I can say my alias for this field should be first name. And then my last name, it doesn't have a default, so I don't need to specify a default here either, and that's going to be last name. And then date, I'm going to make that optional, so I'll specify that equal to none, but I'm not going to give it a field with an alias because they would be the same. So there's no point in me creating an alias with the same name. So now we have our data in our dictionary already defined, right? We have this data dictionary which has first name, last name, date of birth. But we cannot load that dictionary as is anymore, since we specified the field aliases, and those are what Pydantic is going to look for when deserializing the data. So let's go ahead and try that. So we'll say try person.parseObject, and then we'll pass it data. And then we're going to catch the validation exception, and then we'll just print ex.json, for example. So you'll see from the result here that we're getting this field required message that there was a missing value for last name, but look how last name is spelled. Last capital N name, not last underscore name. So we could change our dictionary. We could go ahead and redefine our dictionary this way. And let me paste it here. So now we're using this camel casing convention for the dictionary. And now we could go ahead and say p equals person.parseObject and pass it data 2. And then we look at p, and you see that everything works just as we intended, except it's still showing the field name here in the actual description of the class, the representation of the object, whereas it's using the field aliases in the dictionary here. And the same thing is going to happen with JSON as well. But before we get to that, now that we've seen that in order to deserialize the data, we need to be using the field aliases, not the field names. What happens when we serialize the data? What if we say p.dict? What are we going to get? Well, as you can see, in that direction, it's using the field name, not the field alias. And it will be the same thing with JSON. If we look at the JSON, it's again using the field name, not the field alias. And we'll come back to that in a minute. So we can no longer use the field names when we're creating the object. We can't even do it directly. Like if we do person, and then we specify last name equals, let's say, Newton, then you're going to see that we still get this validation error, and it's still the same thing. Last name is required. We actually do need to pass it as last name this way. So this kind of bugs me because this is not clean Python code. This is not the convention that we use. However, we can actually configure Pydantic to allow us to use the field names as well as the aliases. And to do so, we need to configure the Pydantic model. And this is going to be just one configuration. There's a lot of configurations you can do for your Pydantic models. We'll take a look at another one later on in this video. So let's go ahead and take the original class. That was this one here, right? So we have our aliases defined. So what I'm going to do here is actually construct another class within the class. So this is nested inside that base model person class. and it's called config, and you have to call it that. And there are special class attributes that you can specify to configure your model. And in this case, I'm going to use this one, allow population by field name. And I'm going to set that to true. By default, this value is false. Here, I'm going to override it, set it to true. And when I do this, I can now use a mixture of my field names or field aliases. So I could say first name equals Isaac, and then I could say last name, if I really wanted to, equals Newton, like so. And you can see it worked perfectly fine. Of course, I wouldn't do this. I would always use the field names, not the field aliases, when I'm working with Python code. And now this means that if we look at our data dictionary again, which was using the field names, we can now go ahead and say person.parseObject, and we can pass it data. And it's going to deserialize that perfectly well. Data 2, if you remember, was using the field aliases. And again, we can deserialize data 2 as well without any problems into the same values. Just as before though, serializing the model, so now going from the model to either a dictionary or to JSON, that is still going to use the field names, not the aliases. So if we create this person object, p equals person, first name equals Isaac, last name equals Newton, then you see we have this object here. And if we take a look at the dictionary, then it is using first name, last name as the field names, right? And date of birth. And the same thing if we do JSON, it's also going to use the field names, not the field aliases. However, we can actually instruct the serializers to use the aliases as opposed to the field names. It's very simple. We say p.dict, and then we say by alias equals true. And now you can see it's actually using the aliases instead of the field names. And the same thing works with the JSON. We can go ahead and say p.json by alias equals true. So same as before with the JSON, and that same as for the dictionary by alias. And as you can see, we do have the aliases used for the keys. So this is what I typically do, is that because if I need to deal with JSON, if I don't, then I don't bother. I always use the field names, which is the Python convention. But if I have to deal with the serialization, deserialization with JSON, then basically I configure the class to allow both. And when I serialize, I just specify the by alias equal to true. Okay, so far we've been pretty good about just passing the field names or aliases that we know are valid for the model. But what happens if we don't? Let's say that I have this data junk dictionary, and I'm going to make this equal to the data dictionary, and I'm going to add an extra field to it. Junk, and let's just say extra field. So if we look at what data junk is now, you can see we've got first name, last name, date of birth, and we have this extra field in here. Now let's go ahead and let's create a person object. So we could say person. Now we could say parse object, and we can pass it data junk, like so. And you'll notice that we just get the person object, first name, last name, date of birth. This thing was basically ignored. That's the default behavior. Or we could also have created it this way. It's the same thing. If we actually just basically unpack the data dictionary as keyword, as named arguments for person, it will get the same result. And what happens is that we get the same thing. It's ignored this junk extra field. In fact, we can check that to make absolutely sure that it's not on the object itself. So let's go ahead and let's create p equals person data. So it's the same thing as before, except I now have a variable called p, and I'm going to check if p has junk. But before I do that, let me just check, does it have first name? Does it have the attribute first name? And I guess I need to spell it right. And the answer is yes, it has an attribute first name because we defined our class with that. So it has that. Does it have the attribute junk? So again, we're going to try that. And this time we're going to pass it junk, which was the key that we had, right, in the dictionary that we used to deserialize. And the answer to that is false. So indeed, Pydantic just ignored this extra field. We can actually define how we want to handle those extra fields. And there's three different ways. We can ignore them, which is the default. We could allow them and actually add them as attributes to the instance, or we can forbid them, which will raise a validation exception at runtime if we try and provide a field that is not defined, is not actually in the Pydantic model. So for that, I'm going to import the extra from Pydantic. So from Pydantic, I'm going to import extra. And this is an enumeration that has a few values. If we look at extra, that's just an enum. And we're going to go back to this configuration. So we're going to go back to this class, this one over here. I'm going to copy paste that. And in the configuration, I'm going to add one more. I'm going to say extra equals, and I want extra to be allow. So allow is going to basically allow extra fields. So now let's go ahead and say p equals person, and then we'll again just do it this way. We'll pass the dictionary's key value pairs as named arguments to person. You could also use parse object. And as you can see, junk now is in there, and that is an attribute on that class. If we go ahead and deserialize it, then you can see that it is also in here. So it has been added to the class. Now we can also just forbid it altogether. And this is typically how I do that, because I want to know if I'm trying to set, a field on a model that I haven't defined. I want to know about it because that means I probably just forgot to add it in, or there's something wrong. Something somewhere is returning a field that I wasn't expecting. I want to know about it. I don't want it to be silent. That's my use cases in general. Your use case, of course, may be very different. So here what I'm going to do is I'm going to forbid it. So it's forbid. So now if we try and do this, if we try and say person data junk, now we're going to get a validation error. And we'll be told that junk extra fields are not permitted. So using aliases for proper JSON naming conventions versus proper Python naming conventions, as we've just been doing, is so common that there's actually a much easier way to define field aliases than specifying them for each field. I mean, if you have, let's say, a model with dozens of fields and you have a lot of them with the snake casing, do you really want to have to type alias every time and specify the name? Sometimes you want to do it. For example, you may have something like this where your internal name, let's say you want it to be a type, right? Let's say it's a string, but you don't want that in the JSON. You want that to be, actually type, like so. So you would do something like this. Why? Well, type is a reserved word in Python, right? You don't want to reuse that as a class attribute. So we'd use like type underscore, and then you'd specify the alias. But apart from that, what have we been doing? We've really just taken the snake case and converted it to camel case. If you got to do that 50 times in just a single model and you got dozens of models in your project, that's going to get tedious. So there's a much simpler way to do that. And we're going to create a customized base model class. And then we'll be reusing that class everywhere we want to implement this camel casing and this alias versus field name. So the first thing I'm going to do is define a function. So let's go ahead and say snake to camel case. And we'll take a value string, and it's going to return a string. And then we're going to do it this way. There's probably better ways of doing it. You even have libraries that you can install that will do that for you. But this I found works pretty well, and certainly works well enough for every use case that I've encountered so far. So we'll say, so if value is not a string, so basically this is a function to convert from snake to camel case. So if the value is not a string, I'm going to raise a value error saying no, value must be a string. In other words, don't try and, change from snake to camel, or camelize, I guess you could call it that. Don't try and camelize something that's not a string. That's not supported. Then we're going to split our value. So we're going to split based on the underscore, like so. And then what I'm going to do is I'm going to join now all the different words, but I'm going to title case every single one of them. So what I'm going to do is I'm going to do it this way. I'm going to say value equals string.join. And we're going to take each word. So for word in words, if the word is not, empty or none. So, because it could happen if you've got two underscores next to each other, then you'll end up with basically something that's none in here. So I don't want that. I want to take all the words in words, but what I want to do to each one is I want to title case them. So once we've done this, essentially we now have something that's proper camel case, where the first letter is uppercase, and then each name thereafter, each word thereafter that used to be separated by an underscore is also a capital letter. I don't want the first capital letter, however. So when I return the value, I'm going to do this. I'm going to interpolate value 0, and I'm going to lowercase that specifically. And then I'm going to take the rest of the value from 1 forward. So that's how I convert from snake to camel case. Let's try some examples. Snake to camel, and then let's say first name. Let's make sure that one works. As you can see, it comes back just fine. We can even use like double underscore first name. That will still come back fine. And underscore first name, that will still come back fine as, first name. And so on. You can try with different things and see where it breaks and fix up the code if you need to. So now we can configure our custom base model to specify that aliases should automatically be generated using that function. And I'll add in the other configurations that I want for the custom base model as well. So basically, I'm going to create a new class called custom base model that is going to inherit from Pydantic's base model. We still need that. But I'm not going to implement any fields in here. There's not going to be any class attributes. Instead, I'm just going to do a class config. And in here, I'm going to specify that my alias generator. So now this is a way to tell Pydantic, hey, for the, generate aliases based on a function. And it's going to take the field name, pass it to that function, and that function should return the alias. Well, that's the one we just created over here. So we'll specify that. Then in terms of extras, I'm going to forbid them. So we'll say extra.forbid. And then I'm going to allow population, since I'm using aliases, population by field name. I'm going to set that to true because I want to be able to work with either the field names or the aliases. And now we're going to use this custom base model to redefine our person model. So let's go ahead and create class person. But this time I'm going to inherit from custom base model. And let me change that. I want custom base model defined like that and with a capital B. So custom base model. So I'm not inheriting now from base model to create my Pydantic model. I'm going to inherit from my custom one. But I can now really simplify all the stuff that I've done because I don't need to specify aliases. So I can just say first name is string. That's equal to none. Then I'm going to specify last name string. I will not make it optional, so I don't specify a default value. And for my date of birth, it has to be a date, and I will also make it optional by specifying a default. And so now I can create my person object, and we'll go ahead and say first name equals Isaac. And then just to show you that we could use either, just like we did before, I'm going to do it this way, and then we'll take a look at the representation for P, and you can see it worked just fine. We also can try and specify person, let's say, and we'll specify the last name, which is mandatory. That's Newton. But now I'm going to specify another field called junk, like so. And we get our validation error. Extra fields are not permitted. So everything's working just fine. So there's a whole lot more to Pydantic in terms of defining all these behaviors. So be sure to check the documentation. I have a link for it up in the Jupyter Notebook at the beginning. You'll probably want to read up on Pydantic. There's a lot of functionality. Even though this video is going to be quite long, we're only going to touch, on a few things in the Pydantic library. So now let's turn our attention to a few ways in which we can fine-tune the validation that occurs for various fields, as well as creating more complex field types using both more advanced Python type hinting as well as using composition of Pydantic models. So you definitely need to read the Pydantic documentation for a full rundown of the various fields and types of validations that are built into Pydantic. So let's take a look at a few of the ones that are built into Pydantic, and then we'll look at how to create our custom ones. So from Pydantic, I'm going to import conint, which means constrained integer. And we're going to do a class test. And we're going to inherit from custom base model. So I'm just going to keep inheriting from that model. And I'm going to make an age field, and I'm going to make that a constrained integer. And it's going to be greater than or equal to 0. That's what the GT mean, greater than. So not greater than or equal to, strictly greater than. And then LE for less than or equal to, let's say 150. So when we do this, we've now used Pydantic's conint to basically say this age has to be an integer, because that's what conint is going to define. But moreover, it has to be greater than 0 and less than or equal to 150. So now we can try and test this. We can say age equals 10, and that works just fine. Now if we try and test, let's say with age equal to -1, well, we get a validation error. Ensure this value is greater than 0, right? If we try putting 1,000, we'll get the same similar message, except it will tell us it has to be less than or equal to 150. We could also use the constrained string, for example, to refine our string types. So from Pydantic, I'm going to import constring, and we're going to do another class test, which is going to inherit from the custom base model. And we're going to define our first name, let's say to be a string and optional. And then for the last name, I also want that to be a string, but I want to constrain things a little further. So I'm going to use that constrained string, and I'm going to do a lot of the possibilities here. So we're going to strip the white space. So I'm basically saying, to Pydantic, when you take in the string for last name, strip any white space from the beginning and the end. I also want it to be strict. Basically what strict means is that if you pass me something that's castable to a string, but is not actually a string, I want a validation error. So I'm saying I strictly want this to be a string. Furthermore, I want the minimum length to be 2, and I'm not going to set a maximum length here. I could set max length equal to something. I'm going to use another option that they have called curtail length equals 25. What curtail length will do is that if I pass in more than 25 characters, Pydantic is going to chop it off and only keep the first 25 characters, instead of raising an exception if we had used max length of 25. So now we can go ahead and do this. So let's say t equals test, and we're going to specify last name equal to, and I'm going to put in a lot of spaces here, Newton, more spaces here, and let's go ahead and see what t became. And you can see that it stripped the white space, right? It will strip any white space characters, not just the spaces. Now, on the other hand, we need a minimum length of 2. So let's take a look at this, where I'm basically going to try and do that. I'm going to put a lot of white space in and then put a single character here. But I've got lots of spaces, right? So the minimum length is greater than 2. However, Pydantic is going to strip the white space and then do the validation, and it says, nope, you need at least 2 characters. So the resulting string has to be at least 2 characters, even after it's been stripped. We could also try and pass in this. We could say test last name equals 100. If you remember when we dealt with the person model, we could pass in 100, let's say for first name and last name, and Pydantic automatically converted that to a string. In this case, however, we used that strict. So when I do that, I again get a validation error that it says, no, it has to be a string. And then lastly, let's take a look at when we specify, let's say, last name equal to, and then we'll take the star times 200. So this is a string of length 200, but remember we've curtailed our string. So if we take a look at that, this is just now 25 characters. I'm not going to count them. So as you can see, Pydantic provides a slew of options, and there's a lot more in that link that I have in the Jupyter notebook, not only for these two, constrained int and constrained string, but you have lots of other constraint types as well. You can constrain lists, to specify a minimum length, a maximum length of the list or the sequence. and so on. So take a look at the documentation. Now, if Pydantic's built-in validators are not sufficient, we can actually define our own custom validators. So let's go ahead and do that, because that plays an important role also when we have derived fields in our Pydantic model that are going to basically calculate themselves based on values in other fields in the model. But let's start with just validation first. So let's create a test class, and we're going to inherit again from custom base. And this time I'm going to create something called a hashtag. So that's going to be our one and only field in this model called hashtag. And I'm going to create a validator for the hashtag. And what I want to do is I want to make sure that hashtag starts with a pound, with a hash symbol. So to do that, I'm going to need to use the validator from the Pydantic library. So from Pydantic, I'm going to import validator. And now I'm going to use that. It is a decorator. So I'm going to specify that I'm creating a validator for which field. And I just specify the name of the field here when I do the decoration. So basically validator is a decorator factory. And then we can name this function whatever we want. That is irrelevant. I'm just going to call it validate name or validate hashtag, whatever, probably validate hashtag. And the thing is with these objects is that it is a class method. So this validate hashtag is actually going to be a class method. So the first item we're going to get back, it's going to be bound to the class. And the second item that we can get in here, and we can actually specify more than one, but let's keep it simple now. We're going to get the value. Basically, we're going to get the value of the hashtag. That's going to be our second argument. So with that, we can now validate whether this hashtag is acceptable or not. So we can say if not, value.starts with, and then we'll put the hashtag. And so if it doesn't start with that, then we're going to raise a value error. So when you do the validation should either raise an exception. And if you look at the Pydantic documentation, it will tell you which exceptions are acceptable. Value error is one that is, and in fact that's very often what the case should be. It's a value error. And here you can just put in the message. So hashtag must start with a pound, a hash symbol. And the validator, if it doesn't raise an exception, should return the value that you want to assign to hashtag. So this validator is not only going to validate, but it's also going to potentially transform the data. And this is what I was saying earlier. You can actually use it for doing calculated fields. So here, I'm just going to return the value as is. It starts with a hash. I'm fine with it. You could do things manipulated and say, well, do let's say that dot lower, right? Always make the hashtags lowercase. So you could do that. So now I can create one. I can say test hashtag equals, and let's put in a pound test this way. And you can see no exception. And if we look at the actual value, it's this lowercase test because we did a lower here. Now let's try and do one where we actually don't specify the hash. So hashtag equals test, and you'll see now we get a validation error. It says no, the hashtag must start with that. That was our error message, and this was a value error. Now we can also do other things too, right, with the validator. Instead of raising an exception if the hashtag doesn't exist, we could just, we'll add it in because you just forgot to put it in. While we're at it, we'll also add a constraint that the string needs to be at least 5 characters and should have any white space stripped, and we'll lowercase it as well. So we'll do all that in the validator. So let's go ahead and do that. Let's say class, test, custom base model, and basically let's create our hashtag again. So now I'm going to use the constrained string because I want to set some length on that, some minimum length. So I'm going to set the min length of my string to be 5, and I want to strip the white space. So white space equals true. And I'm going to now add back my validator. So again, I'm going to use that decorator. So validator and we're going to validate the hashtag. So we need to name it the same as the field. And then the actual function name doesn't matter. So validate name, validate hashtag, whatever. And then the first argument is always going to be the class, and then we'll get the value back. And then we'll just say this: if not value dot starts with, and then so if it doesn't start with a pound, then we're going to return, and we'll do an F string, and we'll return the pound, and then we'll interpolate value, and then we'll lowercase it while we're at it as well. Otherwise, it starts with a hash. We'll just return value dot lower, just like we did before. So now we can again test this. We can say test hashtag equals test with the pound. You can see that we get the pound test. We can now also do it without putting the hashtag in, and we should get the same result. But we are getting a validation error that the value needs at least 5 characters. Well, yeah, there's only 1, 2, 3, 4 characters. So what's happening is that the constraint string validation is checking this string after it's done the white space, but before it hits this over here, right? So I'd have to maybe call it test2, and then that will pass. And you can see the hashtag was added and so on. So we can actually define validators that can validate a field based on the contents of fields that are defined above it in the class. And that's important. And also that have passed validation. That's important too. So let's take a look at an example. So from enum, I'm going to import an enum. And then from typing, I'm going to import list, tuple, and union. I think I'm going to need all of those. So now I'm going to create a polygon type enumeration. So class, polygon type, we're going to inherit from enum. And what are we going to specify? I'm going to say triangle. And triangle should be 3. Then I'm going to say tetragon should be 4. That's basically the number of sides. How many sides to a triangle? 3 tetragon. So I'm kind of using, an integer type enum by using them as the integer value of the enumeration being the actual number of sides. And then we'll have pentagon, and that should be equal to 5. And hexagon should be equal to 6. I'll do those. So that's our enumeration. And we can take a look at, let's say, t equals polygon type dot triangle, lowercase, triangle. And if we do that, we can look at t dot value, that's the value 3, and t dot name would be the triangle, right? That string. So now let's go ahead and create a polygon model using Pydantic. So class polygon model, and again we're going to inherit from custom base, and I'm going to define polygon type over here, and that's going to be of what type? That enumeration type. Again, Python understands that as a type hint. Pydantic is actually able to not only understand that as a type hint, but it will be able to validate polygon type as being a valid member of the polygon type enumeration. And then we're going to do another field here called vertices. And I'm going to make this a list of tuples, and the tuples can either be ints or floats. So we're going to use union int, comma, float. So this is the oldest style of doing it if you're using Python 3.9 and below. If you're using Python 3.10 and above, you can, instead of using union, you can write it this way, like so. And I don't suggest that you mix those things in your code. Stick to one or the other. I'm just showing you here that you can use either. But yeah, I'm basically going to take that out because I just don't like mixing the two. Okay, so those are the 2 fields that we have in this model. Now I'm going to make a validator for the vertices. Now, one thing to really understand is that vertices is defined after polygon type, okay? So when it comes to the validation, by the time we start looking at the validation for vertices, we've actually already, well, Pydantic has already handled polygon type and validated it. It may have failed the validation though. That doesn't stop the validator from continuing to work its way through. You remember earlier we saw that if we had more than one validation error, we would actually get that JSON actually contained all the validation errors, not just the first one. It doesn't stop at the first one. So the same thing's happening here. So we've got to be a little bit careful because this validator is going to run on vertices whether polygon type passed its validation or not. So now let's call this function whatever we want. So def validate vertices, let's say. And again, we're going to get class and then value, which is going to be the value for vertices. That's going to be a list now. But in addition, we also have values. And by the way, you need to use those names because Pydantic is looking for those names, values, and it's going to inject that data. If it finds that in that signature for your validator, it's going to add it into values. And what is values? Values is going to be a dictionary that contains all the fields that were validated successfully listed above the current field. So if polygon type validated successfully, polygon type will be essentially a string in this dictionary. The key, right, will be that string, and then the value will be whatever the value was that we passed in when we were building polygon model instances. If it doesn't pass the validation, we'll still get a dictionary here, but it's not going to contain polygon type because that didn't pass the validation. So now that we have that, let's go ahead and say polygon type is equal to, and so this is why I'm going to get it. I'm not going to use square bracket notation because if my polygon type failed to validate, I cannot get the key. Here by using the get, I'm either going to get the key's value or I'm going to get none because polygon type was not in the dictionary. And so now I can say if polygon type, this means that it passed validation. I have a value and it's valid. It's a valid enum, right, of that polygon type enum that we specified here. So if polygon type is basically not none, is truthy, then we can say num sides required is equal to the polygon type dot value. Remember, the value gives us the number, right? So if it was a triangle, then the number of sides required is 3. Or this is the number of sides. Number of vertices. Let's call it that. So yes, it's number of sides, but let's call it number of vertices. And then we're going to check to make sure that the vertices that we're validating now have exactly that number of points in them, right? So you can think of this as a list of tuples that are tuples of 2 values, int or float, for each one. Basically 2D coordinates. And we want at least 3 of them if it's a triangle, at least 4 of them, well, not at least, exactly 3 if it's a triangle, exactly 4 if it's, a tetragon, and so on. So we can do this validation here. We can say if len value is not exactly equal to the number of vertices required, then we're going to raise a value error. Raise value error, and we'll do something like this. I'm just going to copy paste that, so I'm not retyping the whole thing. Basically, it's just an F string. We're going to interpolate the type name and the type value and say, hey, you need exactly this number of things. Otherwise, we're good, right? If none of those things, we're just going to return value. So by default, we'll just return the value because we've basically raised the value error when we needed to. Otherwise, just return the value as is. We're not going to do any more to validate these vertices. And so that's our custom validator that you see can actually use a previous field that was validated before it. So very handy. So let's see how this model behaves. And I'm going to just copy paste this code so I'm not left retyping all this every time. So if we try and do, I guess I called it just polygon in the Jupyter notebook. So let me change that to just polygon. I usually call my models in Pydantic polygon model, person model, and so on, but I wanted less typing for this video. So you can see that this worked just fine. We said a triangle, we specified 3 vertices, it worked just fine. Now let's go ahead and do the same thing, but now what we're going to do is I'm going to specify a complex number. Remember that we really required the coordinates to be either ints or floats. Here I'm going to use a complex number. So we do get a validation error. And we get two validation errors. We're told that vertices 1, 1, the value is not a valid integer, and the vertices 1, 1, the same vertex, so basically item, index 1 and then subindex 1, and it's not a float either. That's why we get two validation errors. It's not an integer and it's not a float. So we can also try this where we specify, let's say, not enough vertices for a pentagon. I've got 3 vertices, but for a pentagon it requires 5. Again, we get a validation error. For pentagon, exactly 5 vertices are required. And of course, we can also do this one where we try and specify a value for the polygon type, which is not part of the enum, like 10, right? 10 is not in there. And if we do that, again, we get a validation error that the value is not a valid enumeration member. Permitted are 3, 4, 5, and 6. So yeah, if I'd done 3, now I would get the other exception that I don't have enough vertices, but that would be accepted. Okay, 3 vertices, however, are required. All right, so there's quite a bit more to validators. So again, check out the Pydantic docs. And then finally, we can create models that are composed of other models, allowing to easily create complex nested models with ease and with full serialization and deserialization capabilities too. And this is where Pydantic really shines. Not that it doesn't already, but this really is very, very useful. For example, let's say that we want to model something like this. And I'm going to just copy that or take a look at the Jupyter Notebook in the GitHub repo. But here's what I want. I want to create a model for posts, for basically like blog posts. And I want the byline being one or more authors. And for these authors, each one should have a first name, a last name, and a display name. There should be this requirement of minimum 2 characters, maximum 20 characters, minimum 1 car, max 20 cars, and so on. So a lot of different requirements. The display name should be optional, but if it's not provided, it should default to the first name and then the initial of the last name. However, we also want a minimum of 1 character, maximum of 25 characters. The title should be required, at least 10 characters, no more than 50, and we want to force title case. And then for the subtitle, it should be optional, and if present, it should be at least 20 characters and max 100. The body of the post is required, at least 100 characters, no upper limit, and then maybe some links, and 0 or more links. And for each link, we need a name, which is required. So if we provide a link, then we need to provide the name, with a minimum of 5 characters, maximum of 25 characters, and a URL. URL should be again required. It should be a valid URL, and it should include the scheme, HTTP or HTTPS. So this is quite a lot, right, that we're trying to define in this model. But you're going to see how simple it is to do that using Pydantic. And to save time, I'm going to copy the code because really there's nothing new in terms, that we're applying here. We're just trying to do a more concrete example. So this is my author class, and you can see I've got a first name. So I'm kind of looking at the smallest elements, right? The smallest kind of atomic parts of this model. One of them is author. What is an author? It has a first name, last name, and a display name. I want my first name to have a minimum length of 1 and a maximum length of 2. And actually I said minimum of 2 characters here, so I guess we could change it to 2, but whatever, you get the idea. Max length of 20, and I want to strip the white space. And the last name, I also want to have minimum length of 1, max length of 20, and I want to strip the white space. The display name, I want to be constrained so that it's got a minimum length of 1 and a maximum length of 25, but I'm going to allow none. So display name is not going to be a required field that we have to pass in when we create author. However, we're going to create this validator display name. Now, I also set here this extra named argument called always equals true. And this forces the validator to run even if display name is none, because if it's none, it's not going to run the validator. But I want it to always run no matter what, because I'm going to set the display name from here if it hasn't been provided. So even though I'm saying this is the default here, that's really just the default because I can't specify something more dynamic here. So I'm going to use the validator to basically have a dynamic default value. So we'll now have this function, doesn't matter the name, value, and values, because I need to know first name and last name so that I can actually get, to construct the display name if it hasn't been provided. Now, just as before, just remember the validator runs even if the previous did not validate properly, if the previous fields did not validate properly. So we need to run our code only if the prior fields validated fine. Otherwise, there's no point because anyway, there's going to be an exception saying, you didn't do something right with first name and last name. So I'm going to make sure that value actually has is not populated, hasn't been provided. So if not value, and I also want to make sure that first name is a key in the values dictionary and last name is also a key in the values dictionary, which means that first name and last name validated fine. So I can move forward. I can grab first name from the dictionary and last name. And then since value was not specified, I'm going to return first name. And then I'm going to take the last name's first character and I'm going to uppercase it. Otherwise, if none of these were true, or if not all of these were true, so if that whole statement wasn't true, then I'm just going to return the value as is. So for example, it could be that somebody actually specified the display name, in which case I'm not going to turn around and muck with it. It's fine. I'm not going to override it. I was just doing a default. Okay, so let's try this class out. And let's go ahead and create an author. So let's say first name Gottfried, last name Leibniz. I haven't specified a display name. And if we look, here's the display name, Gottfried space and then L. So the first name space the last. We could also do this. We could say, let's say, if we do want to actually override the display name, not use the default, then we do it this way. And as you can see, it kept John von Neumann, but the display name stayed at Johnny, which is what we specified here. Otherwise, it would have become John V, right? John space V. Now we can try also and just test out how it works with the constraints. So first name X, which is a single character, and last name, which is 50 characters. So if we look at that, we have a validation error. The last name should not be more than 20 characters. Limit value was 20. It accepted first name as a single character because that's what we ended up doing here with the min length. Okay, so we've got the author done. Now let's go ahead and create a model for the URLs, the links. And you're probably thinking, well, this is going to be tough. How do we validate the URL? How do we make sure that it includes HTTP or HTTPS, the scheme? Well, actually, that's built into Pydantic. So quite simple, which is why I kind of chose that example. So from Pydantic, I'm going to import. And you can take a look, there's many other types of URLs validators in Pydantic. So you'll have to take a look at the documentation and see kind of the different flavors. And we're going to create this link model. And so what was the link? It was a name and a URL. We're going to constrain the name to be at least 5, but no more than 25 characters. And the URL is going to be any HTTP URL. And that is going to validate the URL and make sure that the scheme, HTTP or HTTPS, has been provided. So we've got the link. That's it. So now we can go ahead and try it out. So we could try this example, name Google, URL. So that should work just fine. And indeed it does. You can see that the URL is this any HTTP URL object. It has the actual value. You can see that we even have additional properties for the scheme, the host, the top level domain, the host type, those kinds of things. We can try and do something where we do not have, let's say, a proper URL because we don't have the scheme, right? We're missing HTTPS. And so you can see we get a validation error, that the invalid or missing scheme. Or we could even try something that's not even like a valid URL because maybe we've got spaces in it, something like that. That's obviously total junk. And you can see that we get one validation error for link. The URL is invalid. Okay, so now we've got those two submodels. Now we can create our main model, which is going to use these two, author and link, as models. So from Pydantic, I'm going to need a constrained list. So I'm going to import conList. And now I'm going to go ahead and create this class, this post class. So let's take a look at that. So the post contains a byline, which is going to be a list of authors, but it's constrained list. It is a minimum of 1. So I need at least 1 author per post. And the item type I can specify here is author. So this is how I would specify essentially a list, a constrained list of type author, like so. And then my title, again, constrained. I'm going to strip the white space between 10 and 50 characters. And I'm also going to do something where I'm going to force title case on the title. So I'm going to basically say that I'm going to put a validator on the title. And what I'm going to do here is I'm going to return value and value.title. So if value is none, it's just going to return none. But it shouldn't be none because we're making it non-optional. And it has to have at least 10 characters. But still, I'm going to make sure. And it's going to title case the title. So we can go ahead, it's not complete yet, but we can go ahead and create some instances. So let's do one like this. So post, we're going to set our byline to be a list of authors with first name, last name, and a title with some title. And if you take a look, now our resulting model, well, the byline is, and it uses this other Pydantic model for author. First name, last name, display name was set automatically for me, and my title case was automatically converted. So now let's go ahead and add the subtitle and the body. So we're going to take this. Actually, I'm just going to copy it from the notebook. So again, byline title, just as before, nothing's changed. Validator for the title, nothing's changed. Now I've just added a subtitle, which I don't think I had before. No. So I've added the subtitle constraint to between 20 and 100. And I set it equal to none because I want it to be optional. And then my body basically should be a string, but it's going to be a constrained string because I need at least 100 characters in there. So that's the body. So that's fine. We can test that. We're not quite done yet. We'll need to add the links still, but that's going to be very straightforward as well. So you can see that we have, our author just as before. We've got the subtitle, which was optional, so it shows up as none because we didn't specify it, and then the body. And if we specified the subtitle, could say a slightly long subtitle. I'm just doing that because we need to at least get 20 characters in here, otherwise we'll get a validation error. And what am I missing? Comma. So you can see now we have the subtitle in here as well. Subtitle. Okay, finally, we just need to add the links. So again, instead of me retyping everything, I'll just paste that here. And so all I needed to do was to add this links as a field for my post class. And what is it? Well, this is just a list of link objects, and it's equal to, by default, an empty list. So I didn't have to use a constrained list, conList, like I did over here, because I'm okay with an empty list as the default. And I can specify the Python type hints to say it's going to be links. And that's it. So now you can see that embedded in these models, there's quite a lot that's going on that Pydantic is giving us. So just to recap, everything that we've done, let me go ahead and copy paste this. So this is everything that we've done, right? We defined our author model, then we defined our link model, and then we defined the post model, which uses the author and link models. So this was what I meant about being able to compose models based on other Pydantic models as well. So let's go ahead and create a full post. So I'm going to copy this data. And so we have the byline. We have actually 2 authors here. We've got John von Neumann, and we're going to override the display name to Johnny V. We're going to actually be specific about it. Then we've got Oscar Morgenstern. We're not going to specify the display name, so that should default then to Oscar space M. We've got the title of the book. We've got a subtitle. We've got the body that basically I'm just repeating this 20 times. And then we have some links that we're providing for the post. So if we look at our post object, it has all that information in there. So this is a little difficult to see. You could try and do a post.dict, but I found that that doesn't always display very well either. You can see that now first name, last name, this is on the same line, this is on different lines. So what I like doing instead is just saying JSON and then indent equals 2, for example. Oh, and of course you got to print it, otherwise you're just going to see those \n's. But when you print the JSON, then at least it's properly formatted that way. And of course, we can deserialize the JSON object back to our instance model. So let's say that I had created this, built up this model instance, and then I save it to a database as JSON. Now I need to bring it back into my code as a post object. Well, I would have this string over here, right? So let me grab that string, and let's just say JSON data equals, and then we'll do triple single quotes, and then we'll put that string in here. So this is our JSON, right? This is what maybe we saved it to a file, or we got it from a REST API, or we got it from a database, what have you, but we want to now make a person object back out of it. Well, that's very simple. We'll say p equals post.parse raw, just like we did before, JSON data. And if we look at I'm going to reserialize it just so we can see what it looks like neatly. But you'll see we get the same thing back, right? So it deserialized the data back in. So we can technically also create our model instance piecemeal, but we have to watch out for fields that are not optional. So what do I mean by that? You may not, as you're running your code, you may not be defining, let's say a dictionary or everything that you need to populate your post object with, the byline, the title, the subtitle, and the body and the links. Maybe you're going to do it piecemeal. The only thing you got to watch out for is when you're doing that you're not missing things that are required. So for example, we could go ahead and create a start of a post this way. We could add, we could add both authors right away, or we could just only add one, and then we could append another author to that byline later on. So let's go take that out, and let's only put a single author in here. And then we'll specify the title and the body, since I believe those were required. So now if we look at P, it doesn't have everything, right? It only has one author. It doesn't have the subtitle, that's set to none, right? That was defaulted to none, so it has it. Links is empty, there are no links defined, but that's fine. We actually got, some stout to the model instance. So we could append that author to byline. So byline.append, and then we'll put in that author. And if we look now at P, well, you can see that the byline has both authors. It has John von Neumann and Oscar Morgenstern, right? Or we could just look at p.byline if we just wanted to make sure of that. How did I end up adding it twice? Let me just rerun this. Then we could go ahead and add in the subtitle later, right? So we can build this thing piecemeal. And then for the links, we could add the links. We could basically specify exactly what the links were. But since it's already a defaulted empty list, we could just also say p.links.append and then just append the link, right? You could do it either way. This way, I'll leave that in the notebook, and here I'll show you can do it this way. Because links was already an empty list, right? So if we look at p.links now, that contains our link. And of course, we can now serialize this to JSON. We can serialize it to JSON using aliases if we wanted to. So print p.json by alias equals true, and then we'll indent 2. Okay, and we get the same thing basically as before, except now we're using the aliases. Before we were not specifying by alias, we were getting the field names. The other thing too is that you can actually generate, so this is a JSON document, right? This is a JSON object. It has a schema. There is something called JSON schemas. Pydantic knows about JSON schemas, and you can actually tell it to give you the JSON schema for the model. So we can go ahead and say print and then post.schema.json. So this is going to generate your schema as a JSON string. And again, you can pass in that indent. And then, as you can see, this is actually a JSON schema document. So it even has, the refs for the definitions author and so on. So if you're familiar with JSON schema, this is what you're getting there. And this is one of the reasons also why FastAPI is able to leverage Pydantic in order to do its Swagger documentation. Well, it's able to get the schema for, generate the schemas for the responses and the requests with the FastAPI. All right, so this was a long video. We covered a lot of functionality. And yet, Pydantic has a lot more going on than what we just looked at. It's a fantastic library, and I really encourage you to read more about it. They have really good documentation that's linked in the Jupyter Notebook. So thank you for watching.